Learn the essential techniques for factoring polynomials and algebraic expressions. Factoring is the process of breaking down a polynomial into simpler expressions that multiply together to give the original polynomial. Let's start by understanding what factoring means in algebra. Factoring is essentially the reverse process of expanding or multiplying out expressions. When we expand, we multiply x plus 2 times x plus 3 to get x squared plus 5x plus 6. Factoring reverses this process, breaking x squared plus 5x plus 6 back into x plus 2 times x plus 3. The simplest factoring technique is finding the greatest common factor. First, we identify the greatest common factor shared by all terms in the expression. Consider the expression 6x cubed plus 9x squared plus 12x. Breaking each term down, we see that 3x is the greatest common factor of all three terms. So we factor out 3x to get 3x times the quantity 2x squared plus 3x plus 4. Now let's learn how to factor trinomials of the form x squared plus b x plus c. We need to find two numbers that multiply to give c and add to give b. Let's factor x squared plus 7x plus 12. We list pairs of numbers that multiply to 12 and check which pair adds to 7. That's 3 and 4. Therefore, x squared plus 7x plus 12 factors to x plus 3 times x plus 4. When the leading coefficient is not 1, we use a different approach. Consider 2x squared plus 7x plus 3, where the leading coefficient is 2. First, multiply the leading coefficient 2 by the constant term 3 to get 6. Now find two numbers that multiply to 6 and add to 7. The numbers 1 and 6 multiply to 6 and add to 7. Perfect. We rewrite the middle term as 1x plus 6x. Factor by grouping to get x times 2x plus 1 plus 3 times 2x plus 1. Finally, we factor out the common binomial to get 2x plus 1 times x plus 3. A special factoring pattern is the difference of two squares. The difference of squares pattern states that a squared minus b squared equals a plus b times a minus b. Let's factor x squared minus 25. Since 25 is 5 squared, we have x squared minus 5 squared, which factors to x plus 5 times x minus 5. Another special pattern is perfect square trinomials. The perfect square pattern is a squared plus 2ab plus b squared equals a plus b squared. Let's factor x squared plus 6x plus 9. Recognizing this as x squared plus 2 times 3 times x plus 3 squared, we get x plus 3 squared. For four-term polynomials, we use factoring by grouping. Consider x cubed plus 3x squared plus 2x plus 6. Group the first two terms and the last two terms. Factor each group, x squared times x plus 3 plus 2 times x plus 3. Factor out the common binomial x plus 3 to get x plus 3 times x squared plus 2. Let's review the key factoring methods we've learned. Always start by looking for the greatest common factor. Watch for special patterns like difference of squares and perfect square trinomials. Choose your factoring method based on the number of terms in the polynomial. Always verify your factoring by expanding the result to check it matches the original expression